Welcome to Astronomy Daily, your go-to source for the most exciting space and astronomy news. I'm Anna, and today we've got a stellar lineup of stories that'll take you from the far reaches of the cosmos right back to our own celestial neighborhood. We'll kick things off with a mind-bending discovery from the James Webb Space Telescope that's challenging our understanding of galactic evolution. Then we'll zoom in on the moon as we discuss Europe's ambitious plans for lunar navigation. But that's not all. We'll explore a groundbreaking collaboration between international spaceports, marvel at a cosmic volcano captured by Hubble, and catch up with Richard Branson as he prepares for his next high-flying adventure. Finally, we'll check in on a new asteroid mission that's sending back some breathtaking views of our home planet. So strap in and get ready for a journey through the latest and greatest in space science and exploration. First up today, the James Webb Space Telescope has done it again, unveiling a truly extraordinary galaxy that's challenging our understanding of the early universe. This peculiar cosmic entity, named GSnDG 9422, has astronomers scratching their heads and exclaiming, "That's weird!" What makes this galaxy so unusual? Well, it's not the stars that are stealing the show, but rather the gas. In GSnDG 9422, the glowing gas outshines the light from the stars themselves, a phenomenon we've never observed before. This cosmic oddity appeared on the scene about 1 billion years after the Big Bang, making it a window into the universe's toddler years. Researchers are buzzing with excitement, suggesting that this galaxy might be the missing link in our understanding of galactic evolution. Picture this. We're witnessing a brief but intense phase of star formation inside a dense gas cloud. This celestial nursery is producing an abundance of massive, incredibly hot stars. These stellar powerhouses are bombarding the surrounding gas cloud with so many photons that the gas itself is glowing brighter than the stars. The stars in GSnDG 9422 are not your average cosmic light bulbs. They're cranking up the heat to over 140,000 degrees Fahrenheit. That's more than twice as hot as typical massive stars in our neck of the woods. While this galaxy doesn't contain the very first generation of stars, known as population 3 stars, it does seem to be a stepping stone between those primordial stars and the galaxies we're more familiar with today. This discovery is precisely why we sent the Webb telescope into space, to reveal new phenomena that help us piece together the cosmic story. As we speak, astronomers are scouring the skies for more galaxies like GSnDG 9422, hoping to build a clearer picture of what was happening in the universe during its first billion years. The James Webb Space Telescope continues to live up to its promise, opening our eyes to the wonders of the early universe and reminding us that there's still so much to learn about our cosmic home. Next up, did you know that more than 400 moon missions are planned by space agencies and private companies over the next 2 decades? This could get chaotic. Fortunately, someone is doing something about it. The European Space Agency is taking a giant leap forward in lunar exploration with its ambitious Moonlight program. This innovative initiative aims to establish a constellation of 5 satellites orbiting the moon, providing crucial communication and navigation services for the hundreds of lunar missions planned over the next 2 decades. The Moonlight Lunar Communications and Navigation Services, or LCNS, will enable precise, autonomous landings and surface mobility for various spacecraft and rovers. It will also facilitate high-speed communication and data transfer between Earth and the Moon, bridging the vast 250,000-mile gap between our planet and its celestial neighbor. ESA's Director General, Josef Aschbacher, emphasized the program's significance, stating that it's a crucial step in supporting both the future commercial lunar market and ongoing lunar missions. The agency plans to launch the first component, the Lunar Pathfinder Communications Relay Satellite, in 2026. By 2028, Moonlight's initial services are expected to be operational, with full capability achieved by 2030. The program will prioritize coverage of the moon's south pole, an area of intense interest due to its unique lighting conditions and potential water ice deposits in permanently shadowed craters. Moonlight isn't just about exploration, it's about collaboration and standardization. ESA is working with NASA and JAXA on LunaNet, a framework for lunar communication and navigation standards. This cooperation ensures compatibility with future lunar infrastructures and technologies, paving the way for a new era of international lunar exploration and development. Speaking of international cooperation, in an exciting development for the space industry, 8 spaceports from 6 different countries have recently joined forces, signing a groundbreaking agreement to collaborate and share knowledge. This partnership aims to potentially develop global standards for launch facilities, marking a significant step towards international cooperation in space exploration. The agreement, signed during the International Astronautical Congress in Milan, brings together a diverse group of spaceports, ranging from well-established facilities to those still in the planning stages. Participants include the Mid-Atlantic Regional Spaceport in Virginia, Pacific Spaceport Complex in Alaska, Sweden's S-Range Space Center, and emerging facilities in the United Kingdom, Japan, Australia, and Peru. This collaboration is set to address various challenges faced by spaceports worldwide. By sharing lessons learned and best practices, these facilities hope to enhance the overall resilience and responsiveness of launch systems globally. The partnership will focus on key areas such as infrastructure development, operational procedures, and regulatory compliance. One of the primary goals of this initiative is to establish international spaceport standards. This could lead to more efficient and streamlined operations across different facilities, potentially reducing costs and improving safety in the long run. It's a proactive approach to addressing the growing demands of the commercial space industry and the increasing number of planned missions. As the space sector continues to evolve rapidly, this collaborative effort represents a forward-thinking strategy to ensure that launch facilities worldwide are prepared to meet future challenges and opportunities in space exploration and commercial space activities. The Hubble Space Telescope has once again amazed us with its stunning imagery, this time capturing a celestial spectacle that can only be described as a stellar volcano. About 700 light-years away, a binary star system known as R Aquarii is putting on quite a show. This dynamic duo consists of an aging red giant star, more than 400 times heavier than our Sun, and its companion, a burned-out white dwarf. The red giant pulsates and varies dramatically in brightness, while the white dwarf orbits around it every 44 years. When the white dwarf gets close to the red giant, it pulls hydrogen gas from its larger companion. This gas accumulates around the dwarf star, triggering nuclear fusion and resulting in explosive eruptions. These eruptions send plasma filaments shooting into space at mind-boggling speeds of over 1.6 million kilometers per hour. The force of these explosions, combined with the star's strong magnetic field, creates a remarkable spiral pattern, extending an astonishing 400 billion kilometers into space. To put that into perspective, that's 24 times the diameter of our entire solar system. NASA aptly describes this cosmic display as resembling a lawn sprinkler gone berserk. It's a vivid reminder of the powerful forces at work in our universe and the incredible phenomena that exist beyond our world. Next up, he's been quiet for a while, but he's planning a spectacular comeback. Richard Branson, the renowned entrepreneur and founder of Virgin Galactic, is set to embark on a new adventure that harkens back to his ballooning roots. Branson will serve as co-pilot on the first crewed flight of Space Perspective, a Florida-based company specializing in stratospheric balloon flights. This exciting mission, scheduled for 2025, will offer a unique experience compared to the rocket-powered suborbital trips provided by Virgin Galactic and Blue Origin. Space Perspective's flights will use a giant hydrogen-filled balloon to carry passengers in a capsule called Spaceship Neptune. Unlike the quick, adrenaline-fueled rocket rides, these balloon flights will be leisurely 6-hour journeys, traveling at the speed of the wind. Spaceship Neptune is designed for comfort, featuring large windows, a bar, and even a fully equipped bathroom. While the balloon won't reach the technical boundary of space, it will ascend to an impressive altitude of about 20 miles. From this vantage point, passengers will enjoy breathtaking views of Earth against the blackness of space. Branson's involvement in this venture goes beyond co-piloting. He has also invested in Space Perspective, which has raised $100 million to date. With over 1,800 people already reserving seats at $125,000 each, it seems there's significant interest in this gentler approach to space tourism. For Branson, this flight will be a return to his ballooning adventures of the past, allowing him to compare the experience with his suborbital trip on Virgin Galactic's VSS Unity in 2021. And finally today, the European Space Agency's Hera asteroid mission has recently beamed back its first stunning images from space, offering us a breathtaking view of Earth and the Moon. These images were captured after the spacecraft's instruments were activated for the first time, following its successful launch on October 7th. Hera's primary mission is to follow up on NASA's DART, or Double Asteroid Redirection Test, which intentionally crashed into the asteroid Dimorphos last year. The purpose of DART was to demonstrate a potential planetary defense technique by altering the trajectory of an asteroid. Now, Hera is embarking on its journey to revisit the binary asteroid system of Didymos and Dimorphos. Its goal is to assess the aftermath of DART's impact and conduct a more detailed study of both asteroid surface and internal structure. The images were taken using 3 of Hera's instruments, including the asteroid framing camera, the thermal infrared imager, and the Hyperscout H instrument. Each of these tools will play a crucial role in studying the asteroids once Hera reaches its destination in late 2026. These initial images not only serve as a poignant farewell to our home planet, but also demonstrate the capabilities of Hera's advanced imaging systems. As the mission progresses, we can look forward to more fascinating insights into asteroid composition and behavior, furthering our understanding of these celestial bodies and potentially improving our planetary defense strategies. And that brings us to the end of today's episode of Astronomy Daily. I hope you've enjoyed this cosmic journey through the latest discoveries and developments in space exploration. From Webb's weird galaxy to Europe's lunar plans, and from stellar volcanoes to asteroid missions, the universe never ceases to amaze us. I'm Anna, and it's been my pleasure to guide you through these fascinating stories. If you're hungry for more space news, be sure to visit our website at astronomydaily.io. There, you can sign up for our free daily newsletter, catch up on all the latest space and astronomy news with our constantly updating newsfeed, and listen to all our back episodes. Don't forget to follow us on social media too. You can find us as Astro Daily Pod on Facebook, X, YouTube, and TikTok. Thanks for listening, and keep looking up at the stars.